Hey guys, welcome to another video by That Dentist Guy. Today we will be talking about the one and only dental materials. So what is dental materials and how to cope with this difficult subject in your exams? I know it's a hard ball to take. I know it's difficult to overcome your fears of dental materials with the complex physics and chemistry dealing in with the gypsum products and other physical properties that arise in fluid dynamics. And I know this sounds like a rap, but listen to me. To excel in dental materials, you do not need a sound understanding of physics and chemistry, but a sound understanding of that part of dental materials which deals with physics and chemistry. So most of the people who come and ask me how to deal with these fluid related examples, or how to deal with the correlations of density or viscosity and capillarity, the one thing I'd like to say is you do not need to mug up the definitions. Dental materials in general do not, even the staff nor the exams, nobody wants you to know the exact definition, but what they want from you is a sound understanding of how and why the concepts of these physics and chemistry is used in dental materials. I'll give you a brief example. For example, when you're reading the different types of behavior of dental materials, there are certain behaviors like dilatant behavior or a pseudoplastic behavior or a thermoplastic behavior. All these behaviors, when you see it, or Newtonian fluid, which is quite complex, when you see it directly, you start thinking these seem like complex words that are going to go right above my head. So today I'm going to tell you how you can deal with these concepts. So this will be like a power pack booster for you on how you can orient yourself to learn all these concepts. So the first thing is, for example, when you hear the word pseudoplastic, you have to realize that. Hey guys, welcome to this new format of That Dentist Guy video series. So as we discussed in the earlier part of the video, we're going to be studying about some of the physical and chemical properties of dental materials. So firstly, what is rheology? So basically, rheology is the study of flow characteristics and deformation of fluids. So now before we understand the various types of fluids, we first need to know what is viscosity. Now viscosity basically comes from the principle that when you look at, say, a fluid, the different layers of the fluid flow at different rates. So this may flow faster, this may flow a little bit slower, and this may flow the least fastest, or I don't know, really slow. So when these fluids are flowing at different rates, they produce a lag or delay between the different layers of the same fluid. Now this is what leads to viscosity, or resistance to flow of a liquid, and this happens in extremely dense kind of liquids like honey, in which the viscosity is more. But in liquids which are quite homogeneous and thin, such as water, there is very less viscosity. Okay, and then there is the properties of elasticity. Now when we talk about elasticity, what you need to know is that the property of elasticity is dependent on the stress strain graph, or the curve. So basically, if you plot a graph with, say, stress on the vertical axis and the strain on the horizontal axis, and the extent up till which the fluid or the substance experiences a type of deformation which is not elastic, or as in it does not tend to get back to its original shape, that till that extent is the elastic limit or the elasticity of the material. The longer this part of the curve, the more elastic the material is. Now that we have dealt with these three terms, let's start with dilatants. So the first type of fluid that we're going to be talking about are dilatants. Now dilatants are types of fluids in which the viscosity increases with increasing strain or shearing kind of forces. For example, if you take an empty syringe or a syringe loaded with LA, and you're giving, say, a palatal infiltration, you'll notice that the more pressure you apply, the more resistance the liquid shows to enter the tissue. So the more pressure you apply, the less it flows. So this is the kind of fluid a dilatant is. So examples are agar or alginate type of impression materials, and then there are pseudoplastic fluids. So now these pseudoplastic fluids are quite in contrast to the dilatant type of fluids. These pseudoplastic fluids, they become less viscous or they become thinned out when you increasingly apply shearing stresses. As in when you take, say, a bowl with plaster and you rigorously rotate it extremely fast, or you subject it to very fast vibrations, you'll notice that it becomes thinned out very quickly. Okay, so a very good example of that is plaster itself and certain types of impression pastes. Now coming to the thixotropic type of fluid. Now this thixotropic type of fluid is the type of fluid in which when you apply a lot of shearing stress, and at that particular time the viscosity reduces, as in the liquid becomes thin, but with time, as in it is dependent on time, it starts becoming more viscous again, as in it starts to become more dense kind of fluid later. So examples of this is Prophy jet, as you may Prophy paste. So now Prophy paste, once you apply and you subject it to a lot of shearing stress, you'll notice that it gets really thinned out, as in it's about to flow out of the mouth. But if you allow it to stand in its own box, again it will be thick again. Similarly, plaster, certain types of plaster can also be thixotropic. Now coming to Newtonian and Bingham fluids. Now I know most of you have may have not heard of the Bingham type of fluid, but you might have heard about the Newtonian type of fluid. Now one thing in common between these three fluids is that all of them showed some type of change of viscosity when a type of shearing stress was applied on them. The difference between that and the Newtonian fluid is the viscosity of the Newtonian fluid does not change with any types of shearing stresses. Okay, so no matter what kind of stress you apply, it will behave in the same viscous nature. You might have seen all these videos on Instagram in which they take these Newtonian fluids and they subject it to a lot of pressure and it just flows out everywhere. That is because it does not deform because of the stress. It maintains its viscosity, that's why it comfortably flows out. I'll link a video which will explain further about that in the ending. It's a fun video to watch. The last one is a Bingham fluid. Now this Bingham fluid is a type of fluid which is a solid at low shearing stresses or very low levels of stresses. But the moment you subject it to a lot of stress, it becomes a liquid. It's a scaredy cat. You know what it is. So whenever it's subjected to any kind of stress, it immediately becomes a liquid. So that's it, guys. I hope you like this style of video recording. Like, share and subscribe. We're almost close to 1,000. Cheers. Bye. Have a nice day.
Question.